Hello students, now we will discuss in coordinate geometry section formula. Section formula, suppose this is point O as origin, this is x-axis, this is y-axis. Let point A with the coordinates x1, y1 and point B with the coordinates x2, y2 be the 2 points seen in the diagram. This is point A with the coordinates x1, y1. This is point B with the coordinates x2, y2. Join AB. And point P with the coordinates x, y in between AB and divide AB in the ratio m/n. See in the diagram, on line AB, this is point P with coordinates x, y and divide AB in the ratio m/n. That is, AP upon BP is equal to m upon n. Let it be equation number 1. Now from point A, draw AL perpendicular on x-axis so that OL become equal to x1, the x coordinate of point A. From point P, draw PM perpendicular on x-axis so that OM is equal to x, the x coordinate of point P. Similarly, from point B, draw BN perpendicular on x-axis so that ON become equal to x2, the x coordinate of point B. Now from point P, draw a line parallel to x-axis which meets BN at point R and LA produced at point Q. Therefore, PQ is equal to, see in the diagram, PQ is equal to LM. And LM we can write, it is equal to OM minus OL and it is equal to x minus x1. Suppose it be equation number 2. And PR is equal to MN and it is equal to ON minus OM and it is equal to x2 minus x. Suppose it be equation number 3. Similarly, AL is equal to y1. See in the diagram, AL is equal to y1 which is equal to y coordinates of point A. PM is equal to y is equal to y coordinates of point P and BN is equal to y2 is equal to y coordinates of point B. Therefore, AQ is equal to, see in the diagram, AQ is equal to QL minus AL and QL is equal to PM. So it become equal to PM minus AL. It is equal to Y minus Y1. Suppose it be equation number 4. And BR is equal to BN minus RN. Now Rn is equal to PM. So it is equal to Bn minus PM. It is equal to Y2 minus Y. Suppose it be equation number 5. Now in triangle PAQ, this is triangle PAQ, and in triangle PBR, the angle AQP is equal to the angle BRP. The region is each equal to 90 degree. And angle APQ is equal to angle BPR. The region is vertical opposite angle. They are equal. Now in two triangles, two corresponding angles are equal. Therefore, triangle PAQ similar to triangle PBR. And in similar triangles, the ratio of corresponding sides are equal. Therefore, PQ, the side of triangle PQ upon the corresponding side in triangle PBR is PR. So PQ upon PR, it is equal to AQ, the side of triangle PAQ upon the corresponding side in PBR is BR, and it is equal to the third side, corresponding third side AP upon BP. Let it be equation number 6. Now see equation number 1 and equation number 6. From equation 1 and equation 6, so we get PQ upon PR is equal to AQ upon BR is equal to M upon N. Let it be equation number 7. Or PQ upon PR is equal to M upon N. Now from equation 2 and equation 3, we get PQ is equal to X minus X1, PR is equal to X2 minus X1. Therefore, PQ upon PR is equal to M upon N. This implies X minus X1 upon X2 minus X is equal to M upon N is equal to M upon N. Cross multiply, we get N into X minus N into X1. It is equal to M into X2 minus M into X. Now by rearranging, taking minus X to the left hand side, so we get Mx plus Nx is equal to Mx2 plus Nx1. Now in the left hand side, take X common, so we get M plus N within the bracket into X. It is equal to Mx2 plus Nx1, or X is equal to Mx2 plus Nx1 upon M plus N. Similarly, from equation 7, so we get AQ upon BR is equal to M upon N. Now from equation 4 and equation 5, we get AQ is equal to Y minus Y1 and BR is equal to Y2 minus Y. Therefore, AQ upon BR is equal to M upon N. It is equal to, this implies Y minus Y1 upon Y2 minus Y is equal to M upon N. Again cross multiply, so we get N into Y minus N into Y1 is equal to My2 minus My. So by rearranging, we get M into Y plus N into Y is equal to M into Y2 plus N into Y1. Now in the left hand side, take Y common, so we get M plus N within the bracket into Y is equal to M into Y2 plus N into Y1, or Y is equal to M into Y2 plus N into Y1 upon M plus N. Hence, coordinates of point P are X equal to M into X2, plus n into x1 upon m plus n, and y is equal to m into y2 plus n into y1 upon m plus n. So these are the coordinates of point P which divide AB in the ratio m ratio n. If point P with the coordinates x, y lies outside AB, so we can prove the coordinates of point P are x is equal to m into x2, now minus n into x1 upon m minus n, and y is equal to m into y2 minus n into y1 upon m minus n. That is, if point P lies outside AB, the sign between the terms become negative. Now, easy way to remember, suppose this is point A, this is point B, join AB, this is point P on line AB with coordinates x, y and divide AB in the ratio m ratio n. Then x coordinate of point P we can find by this method. Multiply m into other side coordinates of point B, that it is equal to m into x2 if we are to find x, plus if point P lies in between the point, and minus if point P lies outside the AB. Now point P is in between the AB, so we get plus n into x1 upon sum of the ratio m plus n, and y is equal to multiply m into opposite point B my2 plus n into y1 upon m plus n. So by this method we can find the coordinates of required point P, and if point P lies outside, the sign between the two terms become negative. Now for midpoint AP equal to BP, put m is equal to n. Therefore x is equal to n into x2 plus n into x1 upon n plus n, and y is equal to n into y2 plus n into y1 upon n plus n. Now in the denominator n plus n become 2n, and then in the numerator n is common. So x is equal to n into x2 plus x1 within the bracket upon 2n, and y is equal to n into y2 plus y1 within the bracket upon 2n. Now n cancel with n, also in y n cancel with n. So we get x is equal to x2 plus x1 upon 2, and y is equal to y2 plus y1 upon 2. Or we can write, or midpoint of AB is x is equal to x1 plus x2 upon 2. Means sum of the coordinates of 2 point upon 2, and y is equal to y1 plus y2 upon 2. So this is the midpoint of 2 points. So thank you very much.